Hey guys, we have a this is a Samsung A5 2017 that's in here. This is the logic board. This is a very important data recovery job. Yeah, I mean, I'll show it to you under the overhead view here and you'll see how it looks. It's got significant corrosion and rusting all along the bottom section of the board here. Thankfully, this is not a repair job. We just need to get the phone to turn on so we can recover data. The notes say multiple drops in water. Specifically want their voice, audio recordings, and pictures recovered from the device. All right, so let's get started here. Let's take a look under the microscope. Oh my. Yeah. So since this is a data recovery job, oh my. What we're gonna do, I'm gonna start by just cleaning this. To drown it in alcohol. Brush. I can see a significant corrosion inside the charge port area. So my course of action with this is going to be first actually removing this charge port from the phone, since we're not going to need it for data recovery, and then we're going to just hook it up to a pre-charged battery and into a frame, and then use a micro SD card to transfer all of the customer data off the phone. So let's dry it off here. There is also some corrosion in the top section of the board, but it's not nearly as bad as the bottom. Sorry, camera. Let's grab a fixture, pop it in. Grab our hot air station. Let's apply heat to the charge port area here and get ready to remove it from the board. Yeah, look at that. All right. Now I'm going to grab a multimeter. We're going to go into diode mode. And we're just going to measure around, see if we find any obvious shorts before we try powering this phone on. Alright, so we do find a short here. So this component, I feel like is causing problems. So I'm going to add a little bit of flux and we're going to just remove it because we don't, this component is not going to be required for booting the phone. This is related to the charge port circuit. Alright, So with that chip removed, let's take those measurements again. Still short, so I'll plow through these caps. Now we will measure again. Let's check on this side of the board. Ouch. No short there. Looks good. Just gonna clean those pads. All right, so at this point, I think we're ready to grab a good housing for this A5 phone and see if it boots up. All right, we have a known good frame here. Let's pop the board in. Connect the LCD. We have a battery here that we know is charged up. We will connect it. Try to connect it. All right, there we go. All right, let's prompt to boot, see if we get anything. All right, so we didn't get anything. Let's try shorting the connectors. So it seems like the phone is actually on. We can feel the CPU area is warm. So it seems like the phone's actually turning on. There's just no image. So what we'll do here, take a look at the LCD connector. The connector itself looks good. There is corrosion here in this area. So in the schematics here, we find, scroll up to this section here, we can identify what's called Octa. We search Octa under the troubleshooting section. We can see right here, LCD is still off after power on, which is what seems to be the problem. So we can check, can follow these here. We see that main component for LCD function is U7015. So U7015 shows up here, and we switch back over to the microscope view. We can see that that chip looks corroded. So let's try replacing it and see if it restores our LCD functions. Alright, so this is our donor board here. Alright, so we've replaced the component, and let's try it out. So battery's connected, and let's prompt to boot. So after changing U7015, there's no change. We still have no LCD. So we're going to check this component here. It says if we're missing voltage at C7044 to change, I believe it's the PMIC on this, this device. So let's take a measurement there. Go black probe on ground. Measure here. So we actually have 0.5 volts, which is abnormal. So if this is equal to 3 volts, but it's not, we have 0.5 volts. So it wants us to resolder or replace U5007, which is the PMIC. It's going to be this chip here, PMIC. All right, chip is pulled. Grab our donor again. All right, let's see what we get. And prompt to boot, here we go. Now would you look at that? It looks like replacing the PMIC has in fact solved the problem, and the phone is booting. So let's make sure we can get to the passcode screen here. Awesome. And the touchscreen works, and we're going to be able to achieve a path to data on this phone. So yeah, this phone came in severely water damaged. We ran through our diagnostic and repair process for data recovery. I'll switch over to the display screen here. We can run a bit of a recap. So initially the phone was severely corroded. We cleaned it up. Removed the charge port because it was in horrible shape, and removed a component that was shorting the charge port area. Then when we put the phone into the frame and prompted to boot, it was actually, we could tell it was turning on because it was getting warm. The CPU was getting warm, but there was no image. So we went through, we downloaded these schematics here. We identified how the LCD line worked. It's referred to as OCTA, OCTA. You see here, LCD is still off after power on. We actually jumped right to this component and replaced it because it looked very corroded. That did not solve the issue, so then we checked the voltages, we noticed an abnormal reading here. We were getting 0.5 volts. So we went ahead and replaced the PMIC U5007. So after replacing the PMIC, this phone booted right up. We got into the operating system, which means there is a path to data. This was a successful data recovery job. Since we took off the charge port, you're probably wondering how we're going to transfer the data, but we're actually just going to put a micro SD card into the phone and then just use the built-in file management app and transfer content that way. So we'll be able to do a full data recovery on this phone. I hope you learned something, and thanks for watching. We'll see you in the next video.